Hello again, this is Rashid from Fabrix.ai, here to give you another demo. I wanted to show you some of the new stuff we've done here at Fabrix.ai. In particular, I'd like to focus on some of the things we're doing to make our agents work in production, past the point of the POC, past the point of the demo. So something you may not have seen yet is our agent catalog. That's what you've got on the screen here. This basically shows you the list for whatever Fabrix system you have. It shows you the list of agents that are available for you to use. They're divided into categories. Some of these agents most of them are developed by Fabrix.ai, but some of these might be developed by you. I'm going to show you a couple of examples here. So let's start with this, one of my favorites. I marked it as a favorite here, the CVE Vulnerability Analyst. When you click on it, you get a little bit more detail. You can interact with the agent. We're going to interact with an agent a little bit later on in this video. You can launch the observation, but what I wanted to show you here is that you can see some quick documentation on the agent itself, how it works, and you can get a sense of what ultimately you can expect to see by looking at some screenshots. You can see here screenshots of the types of report that the agent produces, what it looks like when you start it, etc., etc. So when you launch into the environment, this is the first thing you're going to see. You're going to see the main dashboard. This is the AI storyboard, and it basically gives you a bird's eye view of everything that's going on with AI on your particular system. You can see that this system has actually got about 16 different projects. We support organizing agents into projects so that everybody can work on their own versions of prompts, own versions of tool sets, without disrupting anybody else and without creating long lists of agents that people don't understand. And it also allows you to configure different sets of permissions and different sets of rights based on the agents that belong to specific projects. Some of the other things you can see from here, there's a lot of observability built into the platform, but one of the things people often concerned about is how much is this all costing me? So we do offer some visibility into your AI costs. You can track them over time. Pretty much any kind of the same visibility that you would expect to get out of an observability platform, you can expect to get out of the Fabrix.ai agent platform. You can not only look at your global costs over here, but because we are able to organize things in projects, you can actually check the costs of your project. So if I look at my cost analysis here for this particular project, I can see exactly how much money I've been spending, using large language models and running my agents within this particular project. Additionally, within a project, you can gain visibility into conversations. So conversations are agentic sessions. Pretty much any time that an agent runs, either autonomously or interactively, a session will count as a conversation, and you can click into these conversations and look at them in detail to see what's going on. Now, you might be wondering, how these conversations are going. How are these sessions going? How are your agents doing? That's a question that not enough people are actually asking, I think. So we've created something that's rather rare in the industry, where we're looking at the agents as digital workers, and we're evaluating their performance a lot like you would any other worker within your organization. So you can see here this dashboard that gives you a bird's eye view of how the agents are performing on the system. We're tracking these things over time. This is a report that shows you your top performing agents that need some attention, some recent alerts pertaining to the performance of the agents. And you can, of course, drill down and look at how any particular agent is doing. Let's look at this agent over here, where we can see its performance metrics. It's being rated on several dimensions. Some of them are displayed here, and we're tracking that performance over time. So a new data point gets created pretty much for every version of the agent. We mark those as specific milestones, and that helps us track how the agent is performing differently based on different versions of it. And you can see that something's changed recently here as of January 27th. It looks like we're having a few more tool tool errors and some knowledge gaps. So we can actually drill down into that. We can look at individual conversations. We can see the ratings for each one. I can click into this particular conversation that kind of had a low score, and I can review the evaluation of that specific conversation. It's got a score of 5.4 out of 10. And we can see what the particular conversation was about, the outcomes that were achieved, what the exact rating was composed of. The agent scored well on helpfulness and accuracy and clarity, but user satisfaction was low and tool success rate was low. That's kind of what brought the performance down. So we do, the evaluator also computes lessons learned, which are things that are then fed back into the agent for potential improvement. Every agent gets evaluated like this. So going back to the performance evaluation for our agent, we can look at the knowledge gaps that were discovered. And for any given knowledge gap, we have also suggested potential fixes. I can click on one of those, and it will tell me what I need to do in order to improve the agent's performance. In this case, it is suggesting that we add some instructions to the agent's system prompt. It can review this, and based on but on what I'm seeing, if I approve it, it will be added to the agent's instructions, and then we can measure how the agent's performance changes based on those changes later on. Okay, so now that we've looked at how we track and monitor agent performance, maybe I could show you a little bit about the agents themselves and how they work. So there's basically two different types of agents that you'll see inside the Fabrix system. Most of them in an enterprise environment are going to be what we call autonomous agents. An autonomous agent is an agent that's basically running in the background. It's got a job, and it's being triggered either by incidents, events, alerts, schedules. It's got some sort of a background trigger that causes the agent to run. One of the agents that we have running in our environment is the network root cause analysis agent, which is monitoring the network of our lab network for failures and runs automatically to diagnose those failures. So the network is being monitored by our AgentOps platform, which automatically creates incidents when some alerts are observed in the environment. This is one such incident over here that I'm going to open up for you. You can see that some alerts were correlated. There were some related alerts. I have a network map. But the interesting thing is that after the incident was opened, there was an automatic root cause analysis that was performed. So let me set the stage for you a little bit here. What happened here is that somewhere in the lab, somebody made some sort of a typo in a router config, and it caused a link to go down. So the agent is alerted because the incident is created, and it goes about and it troubleshoots this problem. It's got access to all sorts of tools in order to be able to do that. It has access to logs, it has access to incident data, and it has access to router configurations and a number of other tools. So the first thing it does is it goes through a methodical way of diagnosing the problem. And it creates a report that it highlights all of the details, and then it shows you the actual identification of the root cause as well as the timeline. And it will give you an impact assessment and a remediation plan. In this case, it came up with two possible remediation plans. Option one, which is the more obvious one, it identified that the root cause of the problem was that somebody fat-fingered an IP address on one of the interfaces, which caused the OSPF configuration to become invalid in this particular instance. So here's actually suggesting correcting the IP address of that interface back to what it's supposed to be, or alternatively, to modify the OSPF configuration on both routers to be consistent with the IP address that actually was put onto the interface. So it's actually providing two options here. The next thing it does is it submits this particular root cause analysis to a ticket, and then links the engineer back to an approval process. Then another agent called a remediation agent picks that up and implements the suggestion that the root cause analysis agent actually put in place. And it has its own procedure. So it receives the remediation request. It performs a pre-analysis to make sure that the problem still exists. And then it executes the change. And then it verifies that the change was successful. Once the change is deemed successful, it closes the ticket. So the other kind of agent I mentioned was interactive. Pretty much any agent that runs autonomously can also be interactive. The way that we interact with agents in the Fabrix platform is through our copilot, which we call Fabio. And Fabio lets you talk to agents. I'm giving you an example over here of an agent that I was talking to. This particular agent is an agent that I use to manage the lab network. And I was asking it here to verify whether all customer VPNs in this lab network are operating as expected. And it went through and it did a bunch of diagnostics, and it went through and looked at a bunch of stuff. And I had more questions for it. I said, can you please make sure that they all have router configurations as startup config? So it diligently went and did that. And I just basically held a relatively long conversation back and forth with this agent, interacting with it, asking it to set up NetFlow, to fix NetFlow, to fix some connection issues. And I never had to touch the lab myself. The agent was able to do all of this for me, and it was an enormous time saver. So you might be wondering, okay, how does all of this work? How do these agents work? Well, in the case of the root cause analysis, this is how it works. The root cause analysis agent is actually a multi-agent complex. There is an orchestrator root cause analysis agent that calls other sub-agents, each one of them responsible for a small piece of this problem and given unique expertise in how to operate within their own problem spaces. So this has a huge advantage because it allows for the context to be segregated and sequestered per agent. That allows each agent to accomplish more within its own context. But in addition, we do have some of the advanced context management capabilities that we're using inside of each one of these agents. The first thing you might notice here is that I'm actually tracking cost of this particular session. You can see at the top how many tokens were used, how long it took to perform the root cause analysis, and how much it cost. And we can break down the cost by individual agents. You can see the roll-up costs of this particular segment. Here we've got actually 2 degrees of hierarchy where one of the sub-agents is invoking other sub-agents, and we're able to visualize those costs and the contribution of each agent to the total cost. Cost management and cost controls are extremely important, and we implemented that as a base feature of the platform. So let's take a look a little bit at this particular root cause analysis. This is not exactly the same scenario as we were looking at before. This particular case, this is for a root cause analysis that has to do with an application, a web application, where someone indicated that the web application was down. So the root cause analysis agent's job is to try to figure out what went wrong. Well, the first thing it does is it looks at the incident details from the incident management system, and then it starts looking through, okay, this is about an application. How is that application connected to the rest of the infrastructure? So it looks into the application dependency map, which gives it a list of all the devices that are involved in making this application function. That's the VM that the application is running on, the host on which that VM sits, the switch that is connected to that host, the series of routers and firewalls that are connect that host to any backend systems that the application has to connect and communicate with. All of that stuff gets included into this application dependency. And then the agent systematically gets to work. And the first thing it does is it tries to troubleshoot the application itself, just like a human being would do. When it sees that the application itself is doing okay, it starts to look at the infrastructure, and it digs deeper and deeper and deeper, and also looks up change requests from the ticketing system. And if it finds a change request, it reads it. The change request is probably written in plain English, but the agent can understand that. So this is actually what happened here. And you can see that once it read the change request, it was done. So what you're looking at here is actually a sequence of agent calls that the orchestrator agent is calling. This is only showing me a very high-level view right now. I can actually click into the details for this particular orchestration agent's perspective. And now you can see the question, any tools that were called. In this case, all of the tools are invoking other agents, but I can expand those to see exactly which parameters were passed and exactly what response came back from each one of these sub-agents. All right, so this orchestration agent is basically gathering all of the responses from the sub-agents and using those responses to construct its final report. However, I can also look into the details of how any particular sub-agent is running. If I click on this particular Splunk agent, for example, I now see that the green dot is next to that. And if I click on details, I'm going to be seeing the details of how that particular agent performed. And I can see its tool calls. And I can look at here its query and the data that came back from that particular query. And I can see the response that it sent back. Here, this looks a little hard to read, but I can always click on the output to see a more readable version of exactly what it told the agent that invoked it. So what is the output of the orchestration agent? Well, it looks like this. It's a root cause analysis report that, again, details the incident itself. And it shows exactly how it went about its work to try to diagnose the problem. It gives you a complete accounting of what happened, and it shows you the final conclusion, including the timeline. In this case, it was able to determine that the reason that the application was failing had nothing to do with the VM or the application itself or the host that the application was sitting on, or the switch that server was connected to. It was downstream. It detected that there was a firewall rule change that blocked that particular front end's access to its backend database. This is what it found over here. And the way that it did that is it correlated both a diff in the configurations, which came up in a log file. A log message highlighted the fact that there was a configuration change on this firewall, and it went and compared the pre and post configs. And another examination found a change request that actually mentioned this particular change, that it was going to happen as a part of a hardening effort. And so it attaches this to the root cause analysis report. The last thing I'd like to show you is just how it is that our agents are able to do these kinds of operations on large infrastructures and at scale. One of the things that's very unique to the Fabrix.ai platform is we have an advanced context engine, and this context engine and our tooling engine allows the system to perform mass operations on large sets of devices and handle incredibly detailed tool outputs without overwhelming the model. This is a small example I'm showing you here, how we were able to run a SSH command on several devices at the same time, completely in parallel, that the results of that command were stored in a context cache, and thereafter the model calls a different tool to be able to search through that content and retrieve the information that actually answers the question that it was looking for. We have several tools that the agent can use to traverse data depending on the nature of that data, including all sorts of data exploration tools. Okay, so hopefully that was useful, and hopefully it gave you a little bit of an idea of some of the things that we're doing at Fabrix.ai to make agents run effectively, securely, and reliably in an enterprise environment.